Hi, I'm Vaughn Winchell from Howard Community College. This is the third video on derivatives as rates of change for students in my Calculus 1 class, Math 181. In this portion of the lesson, we're going to look at marginal cost, marginal revenue, and marginal profit. This is a business application that comes up in Unit. Okay, so some business vocabulary. In business, revenue means the amount of money that you bring in from selling your product or selling your service. It's the gross receipts. It's the total amount of money coming in. That makes it different from profit. Profit is the amount of money that's left over after you use all that revenue to pay your expenses, to pay for things like office rent and electricity and office equipment and labor. And after you pay all those bills, whatever is left over for you, the operator of the business, that's profit. Revenue depends on the number of items you produce and sell, assuming you sell, a product. Or if you provide a service, the number of hours you spend providing it or the number of times you provide it. Revenue depends on the amount of business that you do, and we let X represent that quantity of business. Usually, it's the number of things you make and sell. Since revenue depends on that quantity, we write it as R of X. The revenue is a function that depends on the quantity. Second main bullet point here, the rate at which revenue changes is called marginal revenue. Margin means at the edges, right? So at the edge, what's happening to the revenue? Your book abbreviates that as MR, and I wish they wouldn't. Since it's the rate of change in the revenue function R of X, it's a function that depends on quantity as well, but it's the rate of change. Marginal revenue is R prime of X, and that's how I'm going to write it. Cost is another function that depends on the quantity produced, right? The more, if I operate a company that makes and sells skateboards, the more skateboards I sell, the more materials I need. The more I need to pay my workers. So my costs go up with the volume of business that I do. And we write cost as C of X, cost as a function of quantity. The rate at which cost changes is called the marginal cost, and the people who wrote your book call that MC, but I wish they wouldn't. I wish they would call it C prime of X. That's marginal cost. So, to summarize, the authors of your textbook said the very same thing I just said, but they said it in fewer words with less explanation. C of X is the cost of producing X number of things. So if I am doing the skateboard business, C of 200 is the cost to make 200 skateboards. This will become important because later I'm going to ask about what is the cost of the 200th skateboard, and that's a different question. C of X is the cost to make a big pile of them, 200 or whatever. R of X is the revenue that I would get from making and selling X of them. R of 200 is the revenue from selling 200 skateboards. Profit is the revenue minus what I pay for my expenses. It's revenue minus cost. And it makes sense then that marginal profit, P prime of X, is marginal revenue minus marginal cost. P prime of X is R prime minus C. Okay, that was definitions of terms. Let's look at an example. This example comes out of that online textbook. It says, assume that the number of barbecue dinners that can be sold, X of them, can be related to the price charged P by the equation P of X is 9 minus 0.03X, where X is between 0 and 300 inclusive. So what they're saying here is if you want to sell X number of dinners, you should price them at P. If, for example, I wanted to sell 50 of these barbecue dinners, then X would be 50 And the price I should charge to sell 50 of them would be 9 minus 0.03 times 50. That would be 9 minus $1.50. That's $7.50. If I want to sell 50 dinners, I should charge $7.50 per dinner. Right? So this P of X is the price I should charge if I want to sell X of them. It tops out at 300 because if X is 300, then this becomes 9 minus 9, which is 0. So if I want to sell 300 of them, just don't charge anything, give them away for nothing. 300 people will take them. In the case of revenue, the dollars obtained by selling X barbecue dinners, they don't do a good job of explaining this here in the setup. So let's go to the next slide, where I said the authors of your book seem to think this can go without saying, but revenue is the number of things you sell times the price you charge for them. So the revenue for selling X things will be X, the number of things I sell, times P of X, the price I should charge if I want to sell X things. So previous slide, I worked out that if I wanted to sell 50 of these things, I should charge $7.50. If I do that, the revenue will be 50 dinners times $7.50. I think if you put the numbers in, this makes some sense. More sense, I hope, than when it's all full of variables. Here's the second thing they didn't do a good job of telling you. To estimate the revenue or the cost for the 101st item using marginal revenue, marginal cost, I'm not going to use 101. I'm going to use the 100th item. So if I want to predict the 101st one, I use the revenue R prime for 100. This goes back to that formula from the first video that a future value, f of a plus h, was f of a, and then the amount of change was f prime of a times h. It was that derivative, but it was at the last known value, not at the value we're predicting. I have more to say about that in the last slide of this presentation. This is the place where people who mess this up, and I hope you will not be that person. Finally, the last thing they're not good about clarifying here is I have two things that start with P. I have price and I have profit. So the profit function is written with a capital P of X. The price function is written with a lowercase p, little p of X. Okay, now let's do this question. Use the marginal revenue function to estimate the revenue obtained from selling the 101st barbecue dinner and compare this to the actual revenue obtained from the sale of this dinner. All right, there's a lot in there. We'll do the math. P of X is 9 minus 0.03 of X, suggesting that if P of X is the price I should charge to sell X number of meals, the formula says that for every 3-cent drop in the price, that minus 0.03x, for every 3-cent drop in the price, I'll probably sell one additional dinner. Revenue of X is going to be X times this P of X. So I've got negative 0.03x squared plus 9x. That's the formula for the total revenue from selling all X meals. Finally, to estimate the added revenue from the 101st meal, I'll use the marginal revenue function. I'll use R prime of X, but I have to stick in the last known value. I'm estimating, I'm projecting into the future, I'm making a guess about that 101st meal. The last information I have is from the 100th. So, okay, all the pieces are in place now. R prime of X is going to be, well, here's R of X. R prime of X is going to be negative 0.06x plus 9, which means R prime of 100 will be negative 0.06 times 100, that's negative 6, plus 9, it's 3. We estimate that selling the 101st meal will bring in an additional $3 in revenue that we didn't have when we sold only 100 meals. Let's see how that checks out. Let's do the math. For estimated revenue versus actual revenue. So in the last slide, I found that the estimated revenue was R prime of 100. It was $3. We can find the exact revenue for that 101st dinner, but we need to be a little bit creative about how we do it. This bullet point right here, R of 101, doesn't tell us how much money from the 101st dinner. It tells us how much money we bring in if we sell 101 of these barbecue dinners. But I could compute that. I mean, I own a calculator. I have a formula. I just plug it in, push the buttons. Easy peasy. If I take that figure for R of 101, the revenue from selling 101 dinners, and I subtract out R of 100, that's the revenue from selling the first 100 dinners, the difference will be the revenue from that last dinner, the 101st. So here's how I find the exact revenue. The actual revenue is R of 101 minus R of 100. Trust me on this. I plugged the numbers in, I did the math. If you plug 101 into the revenue function, you get 602.97. And if you plug 100 into the revenue function, you get 600. So the actual difference between selling 100 and selling 101 dinners is $2.97. So the actual revenue from that last dinner was $2.97. Using the derivative function, we predicted that it would be $3. It's a pretty good estimate. It wasn't perfect, but really, if 3 cents is the kind of difference that will ruin you, you're operating too close to the edge. Okay, the last thing I want to say in this video, I want to talk again about why we have to use R prime of 100 to estimate the revenue from the 101st one. And instead of barbecue dinners that cost somewhere between $0 and $9, let's imagine that you are an executive for a company that builds something a lot bigger and more expensive than a barbecue dinner. Let's imagine you're an executive for Boeing. I looked this up. A Boeing 737 Model 800 has a retail price around $100 million. And it costs Boeing tens of millions of dollars to build. So if you were in charge of operations at Boeing, you might want to know whether the next 737 airliner would be profitable before you went and built it. You'd want to project into the future. The problem is, if you haven't built that $100 million jet airliner yet, you don't have any data from that jet airliner. The only data you have is from the last one or all the ones you've built in the past. So you have to estimate based on the numbers you have, right? To project the next one, which would cost too much to just like take a chance. Yeah, we'll build the thing. We might be able to sell it at a profit. To project into the future, you have to use the data that you have. That's the reason why to project about the n plus first, you have to use data from the first n of them. To predict the 101st, the revenue from the 101st barbecue dinner, we use the data from the information, We use the data about the first 100 of them. To predict whether the 100th 737 will be profitable, the 101st jet airliner will be profitable, we use data for the first 100. Okay, that's marginal cost, marginal profit, marginal revenue. And the trick is it's R prime for the one before they asked her, or C prime or P prime. All right, those are the videos. I will see you in class on Friday.